You can do it if you believe you can. Hi, everyone. In this video, I would like to go through the following major topics. Number one, determine if each relation is a function and state the domain and range. Number two, use transformations to sketch the graph of each of the following functions: y equal to f of x, negative f of x, and f of negative x. As always, as you're taking notes, there are three possible cases, and case one, you can give yourself a check mark if you understand the example completely. Case number two, if you have no idea what is happening yet, you can put an X next to it as a reminder to go back to it and try again and again and again. And of course, case number three, sometimes there's that in between case where you feel like you know it, but you don't really know it that well yet. You can put a question mark there again to go back to try at least one more time. Let's begin. Number one, determine if each relation is a function and state the domain and range. So for 1a, if you look at the graph, by inspection, this is going to be a circle. So you can even write down the circle or write down the word circle. And of course, when you draw a vertical line, immediately notice it crosses more than one point. So the short answer, of course, is not a function. And the reason is because it fails the vertical line test. So again, VLT stands for vertical line test. And it's not a function because it fails the vertical line test. Now, even though it's not a function, it's a relation, and you can still write down the domain and range. In one sentence, domain means all the possible x values, and you can say domain equals to x is an element of real numbers such that x is in between -2 and 2 inclusive. Inclusive means you put the equal sign next to -2 and +2. If you write down the range, again, in one sentence, it means you want to write down all the possible y values. And in this case, the range is going to be y is an element of real numbers such that y is in between -2 and 2 inclusive. 1b, again, by inspection, if you look at this relation, you can draw a vertical line and you will notice no matter where this vertical line occurs, it will always cross at maximum one point. So in one sentence, again, you can say, yes, it is a function because it passes the vertical line test. It's over here. And again, you can state the domain and range. Domain means all the possible x values. Now be mindful here. I'm going to use a different color for your reference. Notice there are arrows here. The arrow means it keeps on going forever. So in the world of this graph, the domain is going to be x is an element of real numbers. Now, if you think about the range, again, it means what are the possible y values? And y is an element of real numbers such that, again, I'm going to erase some of this so you can see the original graph. Notice y can only be smaller than or equal to this number. And this point, by the way, on the graph is 0, 3. So if you think about the y value, y must be less than or equal to 3, just like that. 1c, y equals to 2x squared plus 3x minus 5. So again, there are many ways of doing this question, and I would invite you to think about it from a dual mindset. A dual mindset means, can you understand this graphically? Can you solve this algebraically and do the answers match? And again, that's the best way to double check your work. So again, not to overstate this, I'm inviting you to think about this graphically. Also think about this algebraically. And when they do match, then you know for sure you did it right. So here's the first step. By inspection, if you look at this, this is to the power of 2 or degree 2. So for sure, this is going to be a quadratic function that opens up. So in terms of domain, x is an element of real numbers. Now, range we're going to come back to because we can't really do this until we complete the square. So again, that's one method that you can use to find out the possible y values. So again, you can look at this and say y equals 2. You factor the 2 at the front. You copy the -5 at the end. When you factor 2 to the front, in the brackets, it's going to be x squared. Again, how do we know what the next number is? You always take the middle number divide by the leading coefficient. So in this case, you're taking 3 divided by 2 times x. And again, you can always double check by expanding. If you kind of expand this, you're going to get 2 times 3 over 2x, which becomes 3x. Again, you take the number 3 over 2, and you have to divide this by 2. When you divide this by 2, it's going to be 3 divided by 4. Then you take 3 divided by 4, and you have to square this entire fraction. That's going to be 9 over 16. So again, we're adding, and we're subtracting by 9 over 16. Let's write this better for you. So we're adding, we're subtracting 9 over 16. If you're doing it correctly, you're always going to get a perfect square. So for example, here, you can put a big bracket. You can copy negative 9 over 16. You can copy minus 5. But what happens is this trinomial becomes x plus 3 over 4 quantity square. Let's try this again. 3 over 4 quantity square. Again, I'm going to erase the other rough work so there's more space. So now you can rewrite this. I'm going to move this a little bit lower so you can see. Again, we wrote down domain is going to be x is an element of real numbers. Range we'll come back to after we complete the square. So again, if you expand this, y equals to 2 times x plus 3 divided by 4 quantity square. Now, if you think about 2 times negative 9 over 16, 2 divided by 16 is 1 over 8. So this is negative 9 over 8 minus 5. But 5 is the same as 5 over 1. And of course, you can multiply by 8 over 8, which means you're multiplying by 1. You're changing the form, but not the actual value. So this is going to be 40 over 8. And of course, if you think about negative 9 minus 40, that's going to be negative 49. So let's write this down. Negative 49 divided by 8. And of course, the rest of this you can copy. Now, the reason why this is very useful is because now you can say with confidence that the range occurs when y is an element of real numbers such that y must be greater than or equal to negative 49 over 8. And of course, I'm leaving it as an improper fraction. If you did write this as a decimal, negative 49 divided by 8 would be negative 6.125. So if you want to write it as a fraction, that's fine. Leave it as a decimal, that's fine as well. And of course, they're also asking, is this a function? And of course, since this is a parabola, it's going to open up. So it's a function for sure. So it is a function, again, because it passes the vertical line test. Now, again, I didn't forget the dual mindset. I'm going to sketch the graph right now so you can see why this makes perfect sense. Now, again, roughly speaking, it's not a perfect graph, but it's good enough for the sake of this example. This is the vertex, and we know it's located at negative 3 divided by 4, negative 49 over 8. It's going to be right there. Now, the rest of this, of course, you can find the xy intercepts and so on, but the point is to write the domain and range. So again, by looking at the graph, which I'll label for you, then you can clearly say this is the domain, this is the range, this is the function, because it passes the vertical line test. 1b, you're given a TOV, table of values, and the best way, again, to understand this is to draw that graph because you can activate that dual mindset. So again, in the corner here, very quickly, you're going to see the following. You don't even need a gigantic graph because if you look at the points that are given to you, look what happens. If you look at the first point, 0, negative 1, it's going to be right there. The second point is going to be 0, 0. Immediately, you know it's not going to be a function. Same thing here, 0, 2, and 0, 4. So by inspection, this is not going to be a function because it fails the vertical line test. So not a function. Fails the vertical line test. And of course, you can still write down domain and range. Let's see if I can fit all this in the space. Domain means all the possible x values, and the only x value is going to be 0. Range, of course, on the other hand, you can list them from negative 1, 0, 2, and 4, and I put them in order, just like that. Number 2a, Use transformations to sketch the graph of each of the following functions: y equal to f of x, negative f of x, and f of negative x. So I'm going to use 3 different colors for your reference. I'm starting with blue. That's the basic function. So y equals to x minus 3 quantity squared plus 4. So I go right by 3, up by 4. Now, because this is going to be beyond the scope of the scale, but it's okay. So you go right by 1, up by 1. You go left by 1, up by 1. Again, I'm going to label this for you so you can see where these points are located. The next one's going to be a 4, 5. And this point, of course, would be a 2, 5. So the original graph, roughly speaking, looks like that. That is basically y equal to f of x. Now, if I grab a different color, I can move forward to negative f of x. This means reflected with respect to the x-axis. So 3, 4 becomes 3, negative 4, which is going to be here somewhere. So I can already see the graph is going to go beyond the scale. So you can imagine the graph basically opens down just like that. And of course, if you look at the next case, f of negative x, this means it's reflected with respect to the y-axis. So instead of 3, 4, it's going to be negative 3, 4. Again, I can label this for you. The other points, 4, 5 becomes negative 4, 5. And of course, 2, 5 becomes negative 2, 5. So it's going to be, roughly speaking, right there. You connect them just like that. So there it is, f of x, negative f of x, and f of negative x. 2b, f of x equals to the square root of x plus 4 minus 3. So again, if you think about the first point, it's going to be left by 4, down by 3. I can label this, again, negative 4 and negative 3. The next point is going to be right by 1, up by 1. So when x is going to be negative 3, y is going to be negative 2. And likewise, if you think about the next point, which happens to be the y-intercept, it's going to be a 0, negative 1. So again, if you think about the original function, it looks, roughly speaking, something like that. For your reference, I'm grabbing the same color. If I'm graphing negative f of x, I'm reflecting it with respect to the x-axis. So 0, negative 1 becomes 0, 1. And of course, negative 3, negative 2 becomes negative 3, positive 2. Last but not least, negative 4, negative 3 becomes negative 4, positive 3, just like that. And again, if I connect them, it's going to look, roughly speaking, something like that. Last but not least, if I grab the third color, f of negative x means reflected with respect to the y-axis. So this point remains the same. It's still going to be 0, negative 1. Negative 3, negative 2 becomes 3, negative 2. And of course, negative 4, negative 3 becomes 4, negative 3. And again, if you connect them, roughly speaking, it will look something like that. 2c. Now in this case, notice we gave you the actual function f of x. So I'm going to grab the same colors, green for the next type. So f of x is already given to us, so we don't need to graph it. What we can do is graph negative f of x, which means reflected with respect to the x-axis. So again, 4, 2 becomes 4, negative 2. 2, negative 2 becomes 2, 2. And of course, negative 4, 0 becomes negative 4, 0. You connect them. You can draw a straight line. Here we go. There's a straight line. There's a second straight line, just like that. Again, if I grab another color for your reference, I can graph f of negative x, which means it's going to be reflected with respect to the y-axis. So 4, negative 2 becomes negative 4, 2, which is right there. Again, if I think about 2, negative 2, this is now going to be negative 2, negative 2. And last but not least, negative 4, 0 becomes 4, 0. And again, I can connect them with a straight line that looks, roughly speaking, something like that. Great starter, great finisher. 2D. Y equals to negative 1 divided by 4 times x minus 3 quantity squared. So I would like you to pause the video and try this. And of course, when you're done and you press play again, I'll be right here. So again, if I grab the first color, which is blue, here's the first function. Now, think about the vertex. The vertex in this case is going to be 3, 0. So it's going to be right there, 3, 0. Now, it's going to be an approximation, of course, because if you really go left by 1, down by 0.25, left by 1, and you go down and so on, you could do it like that for sure. But what I'm going to do is find the y-intercept for you. That's a nice approximation. So if I find the y-intercept, I'm setting x to be 0. So notice when I find the y-intercept here, you set x to be 0. So watch what happens. When x is 0, you have negative 3 squared. That's 9. 9 times 1 over 4, or negative 1 over 4, is going to be negative 9 over 4. So again, in decimals, you can say negative 2.25. So I'll use decimals this time just to change it up. And of course, this is going to be one side of the graph. Now on the other side, it's going to look roughly speaking something like that. I'll draw an arrow. It does keep going, but it kind of extends beyond the scale of this grid, which is fine. So there's the function f of x. Now, if I think about negative f of x, again, this is reflected with respect to the x-axis. Notice the 0.30 remains unchanged. 0, negative 2.25 becomes 0, positive 2.25. And again, roughly speaking, it looks something like that. If I grab the last color, f of negative x means you're reflecting it with respect to the y-axis. So 30 becomes negative 30. And of course, this y-intercept, 0, negative 2.25, remains unchanged. So now it's going to be like that. And on the other side will be, roughly speaking, something like that. I hope this makes sense.